This is your similarity notes video explanation for the shadows unit. Anything you see in red, please make sure you write down, or anything that I write down for work. Let's get started here. The first thing I'd like you to write down is the symbol for similarity, and some of you just say that's a squiggly line, or others of you might know that it's called a tilde. So if you ever wanted to abbreviate the word similarity, you could just use that symbol. So fill in the blank with me here. Similar figures. They are figures that have the same shape but different sizes. So what does that mean to have the same shape? We've looked at that a little bit in class, but we have a mathematical definition for that, okay? And so they are considered to be the same shape if their corresponding angles are congruent and their corresponding sides are proportional. Another word for congruent is equal. If you want to, please write that down. And the congruent symbol is the equal sign with the squiggly or tilde on top of that. And what does it mean to be proportional? Well, proportional means that the ratios are the same. And so we would look at the ratio, or we'd write the sides as a fraction in regards to each other. And we'll have a few examples of that here. So let's look at the first example. If you don't have these words written down, go ahead and hit pause, or feel free to pause anytime during this video if you need me to slow down. So we have two triangles here. We have triangle JLK and triangle TSR. And so we're trying to see if they are similar or not. So first of all, we would need to know if all of the ratios are the same. So we have 3/6, 5/10, and 4/8. All of those would reduce to 1/2, so the ratios are the same. And next, to check similarity, we would want to know if the angles are the same. And in this particular example, I'm going to add on the angles, and I'd like you to do that as well. So we're going to have right angles here at K and R, so they're both 90 degrees. And we're going to use one arc at angle J and one arc at angle T, and two at L and two at S. And so the sides are proportional because they all reduce to 1/2. And the angles, one angle from each shape is congruent to another. And so all angles are congruent. And so we would say that these two shapes would be similar. Let's go ahead and look at a few examples here. So are the following polygons similar, not similar, or is there not enough information to determine? So to look at here, we need to make sure that we look to see that we are matching up corresponding sides. So sometimes with shapes, you might have to rotate them. So let's look at this top rectangle here and find the longest side, which is 36. And we need to match that up with the longest side down here, which would be 24. So we want to see what 36 over 24 reduces to. And then we would take the short side here, 24 over 18. Now, if all of these numbers were different, we would need to check all four ratios. However, 36 on the right side here would match up with 24, and 24 on the bottom would match up with the 18. And so we just have two rectangles that, two ratios that we need to check. So 36 over 24, the largest number that goes into both of those would be 6. Oh, excuse me. The largest number that goes into both of those is 12. So 12 goes into 36 3 times, and 12 goes into 24 twice. And for the 24 over 18, the largest number that goes in would be 6. And we would get 4, and 6 goes into 18 3 times. And so we're asking ourselves, are these sides proportional? Do they reduce the same thing? And the answer here is no. They are not equal. So the final answer here for problem A is not similar. And we had enough information to conclude that. All right, let's go ahead and look at example B. So are the following polygons similar, not similar, or not enough information? And so we're going to go ahead and check the side relationships here. So the longest side in the top four-sided figure here is 10. And the longest side down here is 30. And then we need to check 5 and 15. Ten over 30 would reduce to 1/3, and 5 over 15 would also reduce to 1/3. So the sides are proportional on these quadrilaterals. However, we do not know anything about the angles, okay? And so we do not have enough information. They could be similar, but we do not have enough information. And so we can abbreviate not enough information with the letters N, E, and I. And so that would be our final answer for this problem. So the sides are proportional, but however, we don't know anything about these angles. And so this bottom rectangle, or four-sided figure, excuse me, could be just slightly tilted to one side. These do not have to be 90-degree angles. So if you could envision kind of stepping on this top of this quadrilateral and smushing it to the side, it could look more like a parallelogram that's tilted. And there'd be nothing controlling that to be, there's nothing, no symbols or numbers controlling these to be 90-degree angles. All right, so example C. I would like you to hit pause and set up your ratios between here and see if they are proportional. When you have done that, you may go ahead and hit play. All right, so you have checked to see if these sides are proportional or not. And so again, that key thing is to make sure you get your longest side here listed in this top quadrilateral, which would be 35. And we need to match that up with the longest side on the bottom quadrilateral, which is not 18, but it is 21. And then we're going to match up 30 with 18. And we're going to check to see if these fractions reduce to the same number to make these sides proportional. So 35 and 21, 7 goes into both of those. So 7 would go in 5 times, and 7 would go in 3 times. And for this bottom ratio here, the fraction, Looks like 6 is going to be the largest number that goes into both. 6 goes into 35 times, and 6 goes into 18 3 times. And so both of these reduce to 5/3. And the symbols, or excuse me, the angles are marked with the right angle symbol, so we know the angles are congruent. And so that meets the criteria for similarity, that the angles are congruent and the sides are proportional. And so we would say that these are similar shapes. And we can use that similarity symbol as well. So you can either, again, write out the word similar or use your similar symbol there. And let's go ahead and take a look at example number 2. And it states the following pairs of polygons are similar. So they're telling us they are similar. And we need to determine the missing side length. So looking at this figure here, we have one side that's denoted with this letter X here. And so we need to see what we know about the rest of the shape so that we could solve for X. And so on our short sides here, we know that we have a ratio of 20 to 4. And we know that the other side needs to match up. And so we have an X and a 6. So there's 2 different ways to approach this problem. And so we know the relationship from 20 to 4 is being, like, let's say I'm going from the smaller figure to large figure, that would be a scale of 5. So 4 times 5 would get us to 20. And so 6 times 5 would get us to our X here, and that means that that missing piece must be 30. And also, they gave us a lot of information on this shape. They did tell us that this side over here was 30, and both of these sides were 6. And so that was kind of a catch-all there, that that side also must have been 30 as well. So the final answer here for number 2 is that the value of X is 30. And you could even then write X equals 30. Okay, so on to part B here on example 2. We have another situation set up here. We have 2 triangles in this particular example, and we're going to match up so again, the polygons are similar, they're telling us that, but we must find that missing side length. So we have the smallest side here would be 55, 66, then 99, and it looks like then these are oriented the same. The X is going to match up with 55, 6 to 66, and 9 to 99. So we're looking for that ratio. So we have 6 to 66, 9 to 99. What is that correlation there? It looks like that scale factor, 6 to 66, would be a multiple of 11, 9 to 99. So then if I match up my missing piece, X over 55, I see that the X must be 5, so that all 3 sides would have that same scale factor or ratio. So in this particular problem, the value of X would be 5. All right, so we have example C here. Again, I'd like you to try this one and see how you're doing on this. So the 2 figures here, they are similar. I'd like you to go ahead and hit pause and see if you can determine what this missing value for X would be. Okay, let's see what you came up with here. So we have some sort of isosceles triangle here with side lengths the same here. So we have 5 to 20 that's occurring twice, 5 to 20 and 5 to 20. And so let's see here. Um, and then our small side here would be 7 and 2x. So 5 to 20, that would be what sort, you're asking yourself, what's that scale factor? That'd be a multiple multiplying by 4. And so then 7 to x multiplying by 4, we can see here that x must be 28. So these would be your most basic similarity problems where you're just looking for that scale factor. Solving proportions. Some proportions can be solved quickly with a little bit of mental math. So as you can see here, 1/3 equals x over 15. How could we solve this proportion? So a proportion is when we have, it's an equation where we have two ratios set equal to each other. And so we can see there that we want to know what x over 15. So what does x need to be so that this fraction will reduce to 1/3? And that value must be 5. Another one that might be a little bit trickier, but still some of you can solve this with mental math. What over 8 would reduce to the same as 9 over 4? And so you'd be asking yourself, how many times does 4 go into 9? And that equivalent would be how many times 8 goes into 18, making x equal to 18. Other proportions need a little bit of a different approach, however. And so, for instance, 5 over 13 equals 19 over x. That would be a problem that I wouldn't want to figure out in my head using mental math or even without a calculator necessarily. And so we're going to use a strategy, or it is going to be helpful to cross multiply in a problem like this to get started with the problem. And I'm going to show you how that works. And it does work because the cross products of all proportions are equal. I'm going to go ahead and demonstrate that for you. So let's say that I had 1/2, very basic fraction. 1/2 is equal to 5 over 10. Okay, and so if you looked at the cross products here, I'd hope you would agree with me that 1/2 does indeed equal 5 over 10. And so if you looked at the cross products here, meaning 2 times 5, and you'd look at multiplying that, 2 times 5 is indeed 10, and then 1 times 10, that equals, sorry for my sloppy writing there, 1 times 10 is also 10. And you could do this with any example at all. I could even look at 1 over 10. 1/10 would be the same as, or let's even go 4/10 to make it be a little bit, proving a little bit maybe to some of you, like 4 over 10, that would be the same as, let's see, 8 over 20. So 4 over 10 is an equivalent fraction with 8 over 20. And if I looked at the cross products there, 4 times 20 is 80, and 10 times 8 is also 80. So if you start with two fractions that equal each other, the cross products must always equal each other, and that's going to be the strategy that we're going to use to solve examples like this. So let's go ahead and take a look at that. So 5 over 13 equals 19 over x. So the first step is to take those cross products and set them equal to each other. So 13 times 19 equal to 5 times x. So at this point, if you don't have a calculator, you would want to go ahead and grab one so that you can try a few of these examples on your own. And so 13 times 19 we know is 247 with the use of our calculator. And 5 times x is simply 5x. And to then solve this equation that you've set up, we would divide both sides by 5. And 5 goes into 247 49.4 times. So the value of x is 49.4. So let's go ahead and set up B. So this is another problem where we definitely, some of you might have been able to use guess and check to figure this out. However, a guess and check would be more complicated on a problem like this where we have a expression inside of our fraction here. So we can go ahead and set cross products equal to each other. So 9 times 7 is 63. And then 4 times the whole quantity x minus 1. So you're going to want to use parentheses here when you write this out. Oh, my pen was freaking out a little bit there. So 4 times that whole quantity, x minus 1, you would distribute. So 4 times x is 4x, and 4 times negative 1 is negative 4. And so now you would have a two-step problem to solve here. We would add 4 to both sides, so 67 would equal 4x. And then we need to divide both sides by 4. And 67 divided by 4 is 16.75. And we have another example here. Example C. Again, we're going to solve this problem, we're going to set cross products equal to each other. So x times 9, so we're going to get 9x. And then we need to take 5 times x plus 7. So again, you're going to want to use parentheses to notate you need to take 5 times x and the positive 7. And to solve this problem, we're going to distribute the 5 times x and the 5 times 7. So we're going to have 9x equals 5x plus 35. And then we can subtract 5x from both sides. And you don't necessarily need to show that work, subtracting 5 from both sides. I'm going to go ahead and turn off this highlighter tool here for now. So subtract 5x from both sides, we're going to be left with 4x over here and equals 35. Again, 4 does not go into 35 evenly here, and 35 divided by 4 is 8.75. So setting up proportions is a nice strategy, and using cross products is an advantage. And last problem here, we're going to go again. This would be very time consuming to try to solve what the value of x would need to be in both locations for this side to equal 20 over 7. And so setting up proportions to find missing side lengths of shapes is the reason why we want to be able to solve a problem like this. So again, cross products here, x times 20 is going to be 20x, and 7 times this whole quantity, 2x plus 6. We want to use parentheses. We're going to distribute the 7 times 2x and 7 times 6. So 14x plus 42. Subtract 14 from both sides, so we're going to have 6x equals 42. And divide both sides by 6, and the value of x is going to be 7. So this concludes the notes for this video.